Alright, so today we are going to learn about inequalities. Okay, we have this inequality and this inequality. Does anybody remember from elementary school what we call the first one? Okay, I'm looking for the math term. Kimberly? Right, but greater than, less than. But I'm asking, what do you call this one? Okay, listen. I'm going to show you a trick. I'm going to show you a trick so you don't get this wrong from now on. Yes? Okay, so here's how, which is similar to what you're saying. And remember that, because that's a good trick. Okay, which one looks like, most looks like an L? The first one or the bottom one? Top one looks more like an L, right? Than this one. So the one that looks most like the L is the less than. Okay? So that's how we don't. You're going to be doing inequalities in high school next year. So when the teacher says, hey, what do you call this? And you remember that trick. The one that looks like an L, even though it's kind of squished, that's the one that's less than. Got it? So therefore, this one is greater than. So the one that doesn't look like an L is your greater than. So write these names down right next to it, please. Now, I'm going to introduce you to two new ones for most of you. Okay. David, good. So, if you compare this inequality to the first one I've given you, there's an extra little line at the bottom, right? So it starts off being the same. It starts off being less than, but then it also says or. Less than or equal to. Okay? So it has less than or equal to parts. So what do you think we call the last one? Good. Greater than or equal to. Now, we're going to draw 4 circles next to the inequality. 1, 2, 3, 4. And we're going to shade in the last 2. Oops. So 4 circles. The first 2 are what we call open circles, and the last 2 are closed circles. I'm going to go over what's the difference in a minute. Yes, but mathematically, why is one shaded and one not shaded? All right. In elementary school, you used to, fill in the circle with an inequality. Remember that? What inequality would go in here? Use your vocabulary, please. Less than. And in elementary school, your teacher taught you, maybe this was the alligator, right? And what would the alligator want to do? Right. It would eat the bigger number, right? So obviously, to keep the alligator, the Pac-Man happy, it would want to eat the bigger number. So if you did not make it eat the bigger number, it would be upset. So here's what you did in elementary school, correct? Maybe in last year, maybe get something with negative numbers. A little bit more complicated. Greater than. Very good. Negative 3 is actually bigger than negative 9 because of the negative. All right. So in 7th grade, what I get to teach you is how to graph them. Okay? So I give you the inequality x is less than or equal to 5. So everybody write graph, and everybody x is less than or equal to 5. X is less than or equal to 5. The reason I wrote this on top is so when you're telling me your answers, you know how to read it. This problem is read as x is less than or equal to 5. That's how you read this problem. Okay? All right. This is how you graph it. You start off with a number line. So you just kind of draw a horizontal line with an arrow here and an arrow there. Now, whatever this number is, Valerie, pay attention because this will be on your quiz. You put right in the middle, 5. Then you put 2 numbers below it in my class and 2 numbers above it. Okay? So you're just setting up your number line first. You put this number right in the middle, 2 numbers below it, and 2 numbers above that number. That's a 3. We're good? Okay. X is less than or equal to 5. Or equal to. What does that mean? Could it be 5? It could be equal to 5, right? So that means that we have what we call a closed circle. Good. That means that 5 is part of your solution. 5 is actually a number we include. Now, x is less than or equal to 5. I'm looking for the numbers. What numbers can I put in here? What numbers are less than or equal to 5? Is it 4, 3, 2, 1, or is it 5, 6, 7, 8? Which numbers are less than or equal to 5? So that's the way we shade. Why? Listen, if I plug in 4 to this, is 4 less than or equal to 5? Is 3 less than or equal to 5? Yes. If I were to use this number, 6 is less than or equal to 5? It's greater than, so it doesn't work. Do we see that? That's why we shade this way, because these are the numbers that I can plug in and make true. I can use any numbers that are below. How many numbers are after that I not write down over here? Is that it? Just 1, 2? Yeah. Is there like a million numbers that I did not write down? Yeah. I did not write down decimals or fractions or all of it. But there's a ton of numbers. I want you to understand there's a ton of numbers we could use. All right. Let's do number 2. Can you graph x is greater than 4? So we draw a number line. What number goes in the middle? 4. 2 numbers below it. 2 numbers above it. Open or closed circle? Open. That means that 4 is not part of your solution. For example, can I say that 4 is greater than 4? No. That's why it's open. If it had the equal to sign, then we would have a closed OK circle. Now, ask yourself, which numbers are greater than 4? Which numbers? So we're going to shade this way. Are we getting it? That means I can plug in 5 is greater than 4. Is 5 greater than 4? Yes. Is 3 greater than 4? No. That's why we shade this way. We shade the numbers that are possible solutions. Notice that on your do now, did we use an inequality? We used an equal sign, right? This means that there's one solution. It is just n equals 6. The only number I can plug in here is 6. That's it. Just 6. When it's an inequality, is there just one number that fits? No, there is infinite numbers that fit. Got it? All right. Try graphing this one. You graph that one. Look at what we just did. How do we start it? What number goes in the middle? Okay. Did you put 7 in the middle? Then 6, 5, 8, 9. Open or close circle? Close. Which way did you shade? Left or right? Right. How many of you guys got that right? Good. Very good. All right. Let's try some negative numbers. They're the same thing. Okay. Yeah. So, guess what? It's the same thing. What number goes in the middle? -2. What numbers are below it? No. -3, -4. What numbers are above it? -1 and 0. So be careful on your number line. Remember on the number line, everything's kind of backwards. All right, open or close circle? Open. There is no equal to symbol there, so it's an open circle. Now, which numbers are greater than -2? This way. Yeah, that's it. Yeah. Let's do 3 is greater than x. Open or close circle? Good. Now, x is less, oh, I'm sorry. X is greater than x. 3 is greater than x. 3 is greater than x. So which numbers are... We're okay? That one? No. Okay. Let's go back and look at the 5 problems we just did. Maybe they're all on one page. Do you guys notice something when you're graphing? You notice a shortcut. Do you notice anything? It's a shortcut. What do you notice? What do you mean? Yes. What do you notice when you graph it? Is there a connection between the inequality. This is called an inequality. So you notice a relationship between the inequality and the way you graph it. Yes? Mm-hmm. The arrow is pointing the opposite. So here's your inequality. The pink line. Which way is this pointing? And which way is this pointing? Yes? Alright, so Kimberly, you're on the right track. Toad, you're on the right track. Keon, focus on that. So which way is this pointing? 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 Now, let me highlight that more. See, if I draw this as an arrow, which way does it point? Okay, if I draw this arrow again, is it pointing the same way? Now here, this way, which way is this pointing? Do you see how the shading is related? This way, and then which way? Same way. Do you see it? This way? This way. This way. Oh. Why, David? Why is this one? Exactly. Look at where the X is.